Find the area of each rhombus or kite. Part A. So the equation to find the area of a rhombus or a kite is area equals 1/2 times d1 times d2, where d1 and d2 are the lengths of the diagonals. So substituting in the given information from the diagram gives it area equals 1/2 times 5 times 11. Then simplifying gives it the area is 27 5/10. Thus the area is 27 5/10 square feet. Part B. Again, the equation to find the area of a rhombus or a kite is area equals 1/2 times d1 times d2, where d1 and d2 are the lengths of the diagonals. So substituting in the given information gives area equals 1/2 times 10 times 24. Simplifying gives it the area equals 120. Thus the area is 120 square millimeters. In the diagram, polygon ABCDEFGHJK is a regular decagon, inscribed in circle P. Find each angle measure. Part A. The measure of angle KPJ. Notice that angle KPJ is a central angle. So the measure of angle KPJ equals 360 degrees divided by 10, which equals 36 degrees. Part B. The measure of angle LPK. Line segment PL is an apothem, so it bisects angle KPJ because it is an altitude of triangle KPJ. So the measure of angle LPK equals 1/2 times the measure of angle KPJ, which equals 1/2 times 36 degrees, which equals 18 degrees. Part C. The measure of angle LJP. By the triangle sum theorem, the sum of the angle measures of right triangle LJP is 180 degrees. By the triangle sum theorem, the measure of angle LJP equals 180 degrees minus 90 degrees minus 18 degrees, which equals 72 degrees. A regular hexagon is inscribed in a circle with a diameter of 32 units. Find the area of the hexagon. Notice that the radius is 16 units, and the central angle is given by the equation Central angle equals 360 degrees divided by 6, which equals 60 degrees. Notice that the segment from the base of the hexagon to the center of the circle is an apothem, so the top angle in the right triangle shown is a 30-degree angle. Now use the sine and cosine ratios to find the lengths of the legs. So the sine of 30 degrees is equal to the length of the shorter leg divided by 16, and the cosine of 30 degrees is equal to the length of the longer leg divided by 16. Solving the first equation for the length of the shorter leg gives the length of the shorter leg equals 8, and solving the second equation for the length of the longer leg gives that the length of the longer leg is equal to 8 times the square root of 3. Recall that the equation for the area of a polygon is A equals 1/2 A times P, where A is the length of the apothem and P is the perimeter. Notice that each side of the hexagon has a length of 16 units. So the area of the hexagon is A equals 1/2 times the quantity 8 times the square root of 3 times the quantity 6 times 16. Simplifying gives A is approximately 665 and 11/100ths. Thus the area of the hexagon is about 665 and 11/100ths square units. A mirror is in the shape of a regular nonagon with 6-inch sides. What is the area of the mirror? The equation for a central angle is given by the central angle equals 360 degrees divided by 9, which equals 40 degrees. Then notice that the segment from the base of the nonagon to the center of the nonagon is an apothem. So the top angles in the two right triangles shown are 20-degree angles. Because the triangle is isosceles, the apothem is in altitude and bisects the side shown. So the length of the shorter leg of the right triangle is 3. Then use the tangent ratio to find the length of the apothem. So the tangent of 20 degrees equals 3 divided by A. Solving the equation for A gives A equals 3 divided by the tangent of 20 degrees. Recall that the equation for the area of a polygon is A equals 1/2 times AP, where A is the length of the apothem and P is the perimeter. So the area of the nonagon is A equals 1/2 times the quantity 3 divided by the tangent of 20 degrees times the quantity 6 times 9. So A is approximately 222 and 5/10ths. Thus the area of the mirror is about 222 and 5/10ths square inches.